I asked my peers to tell me how math made them feel.
I'm probably not going to use the Pythagorean theorem.
It just makes me feel stupid.
Well, I feel like when you're not good at something and you're forced to do it, can make anyone feel like they have low self-esteem, you know?
Math is probably my least favorite subject.
In the future, geometry probably won't help me that much.
I really don't like math. I'm really bad at it too. I haven't really used it in everyday life except for percentages, so I think what I'm learning right now is pointless.
So why do you think that we learn math?
Because I guess some of it's necessary in our lives, I guess, but otherwise, just because we have to.
It's not a secret, math teachers know it, and after speaking with my peers, I was picking up on the fact that they didn't like their math classes. In America, 1 in 4 ninth graders fail to finish high school. Educators cite math as the major academic reason. We are failing as a nation to adequately teach our students math. In the last 40 years, the term math anxiety has come to existence. I believe the solution to this problem is creating more alternative math classes. With the main question being asked, why do I need to know this? I decided to find out the answer. I used to think the unit circle was a fake construct to make my math class way more complicated. I decided to ask a math teacher all about it.
The unit circle is not made up. The unit circle, all of those relationships are things that are found in nature, which if a teacher is really into talking about that, some of those lessons can be really cool. Like all of these, anything that you talk about that goes on a cycle can be represented in the same type of curve that like a sine curve or a cosine curve can be represented. So like think about like sunrise and sunset or the tide coming in and going out. If you think about it, that's like the exact same graph.
So basically, the unit circle is a tool for measuring all kinds of things in real life. As angry as I was that I hadn't already been taught this connection, I also still wondered why students in general would need to know this complicated unit circle if they weren't going to be using it in their future. Don Kim, the math department coordinator at New Trier Northfield campus, answered my question.
So if you want to go down to the fundamental reasons of why you need the unit circle, you need the unit circle as a basic building block of trigonometry. And so if you want to understand trigonometry, you're going to have to learn those building blocks, such as the unit circle.
I am still left thinking, why would one go through all of these building blocks if they knew trigonometry, for example, isn't a class they will ever take in the future? After asking Arlene Sagan, a math intervention specialist at Niles North, my question, she answered in 2 ways. So that you are able to persevere in solving problems that you've never seen before, so that you are able to communicate your logical thinking and critique the logic of others.
I mean, my geometry students, when we're writing 2-column proofs, obviously they want to know why we have to write 2-column proofs and write down all these things about segments being congruent and, you know, proving triangles congruent. But I think that proofs actually lend themselves really well to being an example for just being a logical thinker. So I always try to introduce, before we start doing proofs, any type of logical reasoning. So we talk about some riddles, we talk about Alice in Wonderland, but then we also talk about some things here. Like if you got caught or you got accused of pulling the fire alarm, right, and you wanted to argue your way out of it, you need to be able to build a logical argument. So that's an example that we use. Like some kid got accused of pulling the fire alarm and how he was able to defend himself. So I do think that that type of logical thinking and reasoning is important, but I do think that there's other ways to help students learn that process aside from just using a math textbook.
I am starting to realize that a big reason we take math is because of the thinking processes that we go through while learning it. This sounds as if people who struggle through a math course but persevere think that somehow it's annealed their character. Dr. Andrew Engelward, the director of the Math for Teaching ALM program at Harvard Extension School, says that when there's the strength of mind argument that studying mathematics contributes to building one's brain muscle in a particularly effective way, a counter-argument to this could be that there are many ways to exercise one's mind. Why do we ask everyone to run laps on a track if some students would rather work out by swimming or rock climbing?
There are some schools where if they require you to take a math, say 151, everybody has to have proficiency in math at the 151 level at a particular, at school A. Let's say that means pre-calculus. But students who feel like, gosh, I really don't want to have to take that course. It's just not for me. Sometimes students can fulfill that logical reasoning credit through philosophy. So they can take a philosophy class for it. No way. You have to be able to work through the Algebra 1, the Algebra 2, the geometry, and have that as really a foundation. I could be wrong, but I certainly, in high school, I don't see that going away. When you think about how old you're going to be going through this, that can set you up for your future track and whatever it is you want to do. But no, I don't see that I don't see those courses being able to be substituted out for something that isn't.
John P. Smith III, an educational psychologist at Michigan State University, studies math education. He says mathematical reasoning in workplaces differs markedly from the algorithms taught in school. Even at jobs that rely on STEM credentials, or science, technology, engineering, and math, require considerable training after being hired.
So the question is, what is the age at which a student decides this is not something I'm going to need in my life. Therefore, from this point on, I'm not going to study these subjects, right? So for example, history, social studies. Why do I need to know social studies if I'm going to be a math teacher? Right? So then at some point, should I have decided, I'm going to focus all my energies on on mathematics and not learn any of the other subjects that I might not need in whatever I decide to do, right? So I guess the argument could be made. So in public education, right, it has been someone sort of decided, every student should know some basic information in order for them to have a better understanding of what these things are, so that when they decide on what they want to do, they can make an informed decision, right? And basically in this country, they've decided that high school is you still need to take some core subjects in the core classes, and that would give you the foundation to make those decisions.
Math is critically involved in so much of humanity's progress that it is almost impossible to conceive of our world today without it. However, to the students who know they won't contribute to the world's progress in this scientific way themselves, this argument is meaningless. John Bennett leads a TED Talk entitled, "Why Math Instruction is Unnecessary."
But think about it for a second. 300 million people in the United States, 1.5 million engineers. That's 0.5%. Let's double that number. For every engineer, let's say there's another person who uses some math in his or her job. That's still only 1%. Whoa, how many percent does that make of that people that don't need higher math? You guessed it, 99% of us. When do you use math in real life? Think about it for a second. First thing I bet you came up to your mind was money, right? Yeah. Financial stuff, budget, taxes, balancing your checkbook. I get that. Well, what do you need for that? You need counting, estimating, adding, subtracting, multiplying, dividing. Decimals, the 2 decimal places, not rounding the nearest 10,000th place or something like that. We don't need that. Okay, what else? Maybe you do some cooking or carpentry and you need some basic fractions. Basic fractions, not 2/5 plus 3/7 and common denominator and blah, blah, blah. You throw in 20% off at the mall, 15% tip at a restaurant. You need some basic percentages, and that is it. How old were you when you learned this stuff? 10. I usually get the answer around 10. So just for the sake of argument, let's say at the end of elementary school, you have learned all the math that you will need in real life. Then what the heck are we learning this middle school and high school math stuff for? It's got to go.
We can still develop the thinking skills we want in a student without these advanced math classes that have no application to real life. Dr. Andrew Hacker, an author and professor of political science and math at Queens College, wrote a famous op-ed piece entitled, "Is Algebra Necessary?" He writes, "Instead of investing so much of our academic energy in a subject that blocks further attainment for much of our population, I propose that we start thinking about alternatives." Mary Joy Heineman is a math teacher at ETHS. She runs an alternative math class that has real-life application.
Geometry and construction is a class that is driven by how you build a home. So like the geometry is written, the class is written in an order that follows how you would build a home. So the first thing you would do is look at, a blueprint, right? Or an architect's drawing. What happens if you only have measuring tape? You don't have a protractor. Why would you have a protractor? You're out on a build site. And so there, I know you learned this in geometry, then you can actually mark off a 3, 4, 5 right triangle. And if you can do that, you've got a right angle. And then if you're looking at a rectangle, if you've got your right angles, you can check all 4 right angles, and then you just check to see if the diagonals are congruent. And that's how you would know you'd have a rectangle outside. Our architect draws our pictures in 1/4 inch scale, so a 1/4 inch scale is a foot. And then we talk to the kids about what does that mean in geometry class? Well, that means we're looking at similarity. And so, you can use proportions to solve for different lengths, or you can actually use a tool called an architect scale. It's really great to see and to work with things, tools that we talk about in class, like the math stuff that you need to know. It's really nice to see why it's necessary at all. I don't get that question where why do I ever have to know this? That doesn't happen in this class.
So if we had enough students to run sort of this math class where each student is able to explore math, and the teacher sort of acts as sort of a guide, right? I think that would be a very interesting class to run.
The state regents and legislators, and many adults, are adamant that every young person should be made to master polynomial functions and parametric equations without asking themselves why. There are many defenses of teaching higher math unsupported by research or evidence, or based on practicality and wishful logic. This debate matters. Let's keep asking why. And maybe in the future, alternative math classes will start to replace the classes we are forced to sit through today.